Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, my name is Willy, and in this video I'm gonna show you how to make a CNC program, especially milling and turning on Sinutrain. First of all, you need to open the Sinutrain and use the template. I'm gonna use milling machine first, and after that you need to increase the spindle rotation and feeding scale to 100%, and don't forget to turn it on. After that, you go to the program manager, put your cursor on workpiece, click new to make new directory, and name it anything you want, and click new to make new program. First, I'm gonna use the G-code program, and we click the G-code and click OK. After that, you will got this view to make your program. First, we make the header. We type G17 for the milling operation, G19 for absolute point, G54 for the 0 point, and G71 for unit selection, which is we use metric system. If we want to use inch system, we use G70. After that, we need to select the tool, and in this case I'll use the diameter of tool, which is 10 millimeters, because the outer part of the workpiece that we will make is 5 millimeters long, so it will be easier if we use 10 millimeters cutter, because it will make the coordinates unchanged. After that, we put the information of spindle rotation, feed rate, and the direction of the cutter rotation, which is M3, means clockwise rotation. After that, we click the various to input the information about the dimension or the blank of the workpiece. Next, we need to put the cutter on the machine with G0, which is a rapid move without cutting, so we put the cutter on the coordinate like this, and we need to put the cutter down onto Z-5 because the depth that we will make is 5 long. After that, we need to input the outer coordinates to make the cutter move on that way, like this. Use G1 to make linear cutting. We can just type the change part and not type the same part. For example, if we want to change the X part or the X coordinates, we can just write the X and leave the Y up. We use the G42 to make right compensation radius like this. With that, we can type the coordinates, and it will make the outer part of the cutter touch that coordinate, not the middle of the cutter. Use G2 to make the circular cutting clockwise, and G3 to make circular cutting counterclockwise. And we need the I and G part, which is the relative distance from start radius into the center radius from y-axis and x-axis. Use G40 to cancel the radius compensation. Let's try the simulation. There's something left, and we got the warnings because we haven't ended the program yet. So we need to put the cutter on that direction and end the program with M30. And this is the result. Let's check the simulation and see what happens. And this is the 3D view of the workpiece. Okay, next we use the Shopmill program, which is much easier than the G-code. We do the same steps at the beginning, which is make the name of the program, but don't forget to change the type of program into Shopmill like this, and then click OK, and you will be redirected on this view. Fill out the header program by filling in the information of x0, y0, and so on like this. We put the safety distance on 1 millimeters. So in Shopmill we need two contours, which is out and in contour, and we click the spigot feature to make the plane between the two contours are cut. First we make the outer contour, which is we just need to put the information about the coordinates that we had done before, and after that we make the inside contour like this. Next we click the spigot feature and we fill in the information about the tools, feeding, and the spindle rotation, and we can use the roughing and finishing at once, but we do it separately. So we need to do the roughing first. Z0 is 0, Z1 is the depth, which is 5, dxy is the percentage of the movement cutter, which is 40%, dz is the maximum depth of cutting, uxy is the plane that we will left for the finishing part like this. After that we click the spigot again, and now we will use the finishing part, which is wall finishing, and we put the information like before and click accept. Let's see the simulation. The result will look like this. For safer operation, we need to cut the workpiece twice, not just right 5 millimeters depth, but we need to cut the workpiece like probably half of the depth. So we need to change the DZ on the roughing part like this, which is we put like a 2.5, and then the result will be like this. So let's move into the turning machine on CNC program. So what's the difference between turning machine and milling machine? It has a different axis. So we know that in milling machine we use X, Y, and Z axis, but in turning machine we only use X and Z axis. X axis is for the vertical movement of the cutter, and the Z-axis is the length of the workpiece. So for example, in this picture we see that the length of the workpiece is 138 millimeters, so that is the Z-axis. And what about the X-axis? The X-axis is on the diameter of the workpiece. So how we make the CNC program on the turning machine? We also do the same on this machine as the milling machine, that we make the header, which a little bit different in the first number, which is in milling machine we use G17, but in turning machine we use G18. That's the difference. After that we select the tool, which is I use the finishing tool because I'm gonna go the roughing and finishing part at the same process. Okay, next we put the information about the limit speed of the spindle rotation, which is in this case is 3000, After that, we put the G96 for the constant speed, which is as you see 4000, and next we type M3 and the feeding information. After that, we click the values for the blank or dimension of the workpiece, and we put the information in this blank and accept. Next, we put the cutter in the safe place but near the workpiece. For example, we put the cutter in that coordinates and we put the cutter down like this. We use G0 for the rapid movement and without cutting. After that, we use contour call feature and name it, for example, wheel 1. And after that, we use the stock removal. And imagine that you have the contour, but actually you don't, but imagine that you have it like this. Put the information about the stock removal. We can use the roughing and finishing at the same time. We use longitudinal direction and the outside cutting like this. Okay, like we did before on milling machine. After that, we put the cutter on the same place like before. We use G0, and next, because the workpiece that we will make has two directions, which is has a radius on the back side of the workpiece, so we need to use another tool in other direction. We make the contour call, the second contour call, we name it wheel 2 and accept, and next we use stock removal, and imagine you have the contour like this. We fill out the blank like we did before. And after that, we put the cutter on the same place again, and next we make the plunge or groove. We click the turning and we put the cursor on groove and click it, and we fill out the blank, which is the information about the coordinates of the groove, the width of the groove, the depth of the groove. But remember, the depth is divided by 2 because in the picture there are 2 grooves, which is up and down, and we need to divide the depth groove by 2 like this. And after that, we click accept and we put the cutter on the same place, but before that we need to change the tools into the plunge tools like this, and don't forget to add M6 for tool change. After that, we make the thread by click the turning and click thread menu like this. And we fill out the information about the type of the thread, which is isometric, and the size of the thread, which is M16. We also can use the digressive a system of the cutting, and we put the outer thread like this. We put the information, the x0 and the z0, the zi, which is the length of the thread, next the lw, which is the beginning part of the thread, and next we put the information like this, and after that we click accept. Don't forget to change the tools into the thread tools like this. We select tool and we click threading with 2 metric like this. After that we put the cutter on the same place again, and we do the last contour, which is we need to cut off the workpiece with radius. We click the turning and we click the cut off menu like this and fill out the information like this, and the radius is 4. The x0, the z0, and the radius, and so on like this. After that we click accept and we change the tool. We use the tool as the same as we make the groove like this, and don't forget to add the M6 for tool change. After that we put the cutter on the same place again, on the safe place. We use G0, and the last is we need to end the program with M30. But it's not over, it's not finished. We haven't made the contour. So what should we do? We should make the contour by click the contour part and click the new contour like this. And after that we make the contour that we need, like we do the Shopmill like this, and we need to name it as the same on the program before, on the stock removal. We make the contour wheel 1 first like this, and we put the information about the coordinates on this part. After we finish the wheel 1 contour, we make the new contour to make the wheel 2 contour like this. And after that, let's see the simulation. And this is the simulation of what we have done. And there you go, you have finished this. And that's all from me. I'm sorry if I made so many mistakes in this video, and thanks for watching. See you. Wassalamualaikum warahmatullahi wabarakatuh.